Let us study significant figures. At first, let's define it. This is if in a measurement, in a measurement, in a measurement result, in a measurement result, this is in fact some figures or some digits. Okay, the digits that are known reliably plus first uncertain digit. In a measurement result, reliable digits, reliable digits plus first uncertain digit plus first uncertain digit. This is a significant figure. Okay. So you can say that the digits that are known reliably plus first uncertain digit are known as significant digits or significant figures. Okay. In a measurement result, there are many reliable digits and there are many uncertain digits. Okay. The first of that uncertain is added to the reliable digits, then the total sum is significant figures. Okay. This is a definition. Let's see one example. The example, it can be, suppose that there is a measurement of a distance that is 275.6 meters. Okay, and this is a distance is measured 275.6 meters. Here 275 is a reliable, it is certain, and 0.6 is uncertain. It can be somewhat more, somewhat less, it can be. Okay, but this is sure. So this comes under reliable digit category, and this comes under uncertain digit, and this is the first uncertain digit. So the significant figures defines that reliable digits plus first uncertain digit. Okay, this is a significant figure. Any example we can take. This is for, suppose that for second we take 5 minutes and 30 seconds. Okay, it can be written as 5.5 minutes. Okay, here this is a reliable digit, 5 minutes, this is exact data, and point 0.5 here it can be doubted upon. So this comes under uncertain category, and this is the first. Suppose that this is 5.556, this is minute. Okay, in such situation we take this one as the fixed category, reliable category, and this is first uncertain. 3 uncertain, but we take the first uncertain, so it is significant means that defines the data, which is that defines the measurement data which have reliability plus a first uncertain digit. There can be many uncertain digits, but first one is taken as significant figure. Okay. Now we study rules of counting significant figures. Okay. Now rule number 1. That is the first rule. First rule tells that all non-zero digits are significant. This simple rule. All non-zero digits are significant. All non-zero digits, for example, you can take suppose that 3, 4, 5, 6, 7, 8. These are non-zero, so it has 6 significant 6 significant figures. This is simple rule. All non-zero digits are significant. Now rule number 2. Rule number 2 says that all zeros between two non-zero digits are significant, no matter where the decimal point is. Okay, so we can write all zeros between two non-zero digits, between two non-zero digits are significant no matter where the decimal point is. Where the decimal point is. Okay. Here we will stand with an example. Suppose there is one example. Here it says all zeros between two non-zero digits are significant no matter where the decimal point is. It doesn't matter where is the decimal point. If we see zeros between two non-zero digits, they will be significant always. For example, let's see 5 double zero. So suppose it's 00075. Here all the zeros. These three will be calculated as significant, and the non-zeros are always significant. So it has 6 significant digits. 6 significant digits. And also now if we see that suppose there is another example 5.0075. If this is the number, and we have to calculate the number of significant digits 1 2 3. These are non-zero digits, so they are significant, and these two will also be significant because they are between non-zero digits. Okay, if the zeros are between non-zero digits, they will be significant. So 1 2 3 4 5 significant digits. Okay, and any example we can take. Suppose that it is 60.76. This zero will also be significant. Why? Because all zeros between two non-zero digits are significant. Look at this zero lies between these two non-zero. Okay. Now let's see the rule number 3. The rule number 3 says that if the number is less than 1, this rule belongs to the number less than 1. It means, for example, let us take one example. For example, we can see, let us take one number which is less than 1, that is 0.00473. Okay, this number is less than 1. Clearly it is less than 1. Okay, we can see zeros on the right side of the decimal point, and the definition says zeros on the right side of the decimal point. This decimal point, this is the decimal point, and zeros on the right side. This is the zero on the right side, and to the left side of the first non-zero digit. Let us see the first non-zero digit is this 4. This is the first non-zero digit. The left side of the first non-zero, these two. So these two will be not significant. Okay, the definition says if the number is less than 1, this number is less than 1, the zeros on the right side of the decimal point, the zeros, these two zeros are on the right side of the decimal point, and to the left side of the first non-zero digit are not significant. First non-zero digit is 4 and the left side is these two. Right of the decimal point and left of the first non-zero digit, the zeros will be not significant. So it has 3 significant digits. Okay. Suppose one other example, any number less than 1, that is 0.00, any number of zeros we put after one non-zero digit, before one non-zero digit, this is less than 1. These these 4 zeros will be not significant according to rule number 3. Okay. And now next rule. Now let's see rule number 4. Rule number 4 says that trailing zeros are not significant in a number without a decimal point. Let us take one example. A number without decimal point having some trailing zeros. Suppose that 4, 5, 6, 0, 0, 0. Okay, this is a number. This is without a decimal point. This has no decimal point, this number. Okay, and the trailing zeros means, trailing means terminal, last. The zeros in the last of the non-zero digits. Okay, this is called trailing zeros. Trailing zeros, these three are trailing zeros. The trailing zeros will be not significant. This rule says that, rule number 4 says that if a number has no decimal point, no decimal part, okay, any number you can say, suppose it is 2, 5, 7, 0. This has no decimal point. The trailing zero, if a zero will occur in the last, this will not be significant. Okay, so looking at this will have 3 significant figures only. This will have 3 also. The zeros will not be counted. Okay, this 0 will also not be counted. How to recognize this? We will see at first, is it having a decimal point or not? It is not having a decimal point. Then zeros are trailing. This will not be counted as significant digit. Okay. Now rule number 5. Rule number 5 says that trailing zeros are significant in a number with a decimal point. The rule number 4 was with a decimal, without a decimal point. Now let's see example with a decimal point. Okay, the decimal point is 4, 5. Suppose the number is 456.000, and this is, in this example we see that this has 3 trailing zeros. The trailing zeros are significant in a number with a decimal point. This number has a decimal point, okay, and 3 trailing zeros. This will be significant here. This was rule 4. Rule 4 says that without a decimal point, the trailing zeros are not significant. And rule number 5 says that with a decimal point, the trailing zeros will be significant. So these 3 will be significant. And here the significant figures will be 6. Suppose another example, 257.0, one trailing zero in a decimal point. This will be significant. Okay, so at first we look whether it is having decimal or not. If it has decimal, this will be significant. If there is no decimal point, this will be not significant, like in rule 4. Okay, so this will have 4 significant figures. Okay, now next rule. Rule number 6 says that the number of significant figures does not depend upon the system of units. To understand this, let us take one example. The example is, suppose there is a distance 0.0000154, this kilometer. We can convert it in meter also. Meter, it will be 154, 1.4, no, 0.154 this meter, and in centimeter it will be 15.4 centimeter. These all the three lengths are same. Okay, one is in kilometer, another one is in meter, and another one is in centimeter. Now let us count the number of significant figures. Here it will all are non-zero, and this has three significant figures. All are non-zero. This has three significant figures, and this is having some decimal point and 0 after a decimal point. So the rule number 3, what does it say? If a number is less than 1, zeros on the right of the decimal point and to the left of the first non-zero digit are not significant. So these three will not be significant. So this also has three significant figures. Okay, so the rule 6 says that the number of significant figures does not depend upon the system of units. It is independent of the system of units. Although there is some ambiguity in significant figures, this will be extended in the next video. Okay.